Have you ever looked up at the moon and noticed that something seemed different? A shadow begins to creep across its familiar face. The bright silver light slowly fades. And then, instead of disappearing into darkness, the moon begins to glow red. Sometimes copper, sometimes orange, sometimes a deep, smoky crimson. For a little while, the moon seems to have become an entirely different world. But the moon itself hasn't changed. The light reaching it has changed. A lunar eclipse is really the story of sunlight traveling around Earth to find the moon. The Earth circles the sun, the moon circles the Earth. Most of the time, sunlight reaches the moon without anything standing in its way. But occasionally, the sun, Earth, and moon move into an almost perfectly straight line. This time, Earth is in the middle. As the moon travels behind our planet, it begins to enter Earth's shadow. From the ground, it looks as though something is slowly taking a bite out of the moon. The shadow grows larger, the moon grows dimmer, and if the alignment is just right, the entire moon passes into the darkest part of Earth's shadow. This is a total lunar eclipse. But if Earth is blocking the sun, why doesn't the moon disappear completely? The answer is hidden in the thin layer of air surrounding our planet. Even while Earth blocks the sun's direct light, some sunlight passes through Earth's atmosphere. As it travels through the air, the shorter blue wavelengths of light are scattered in many directions. The longer red and orange wavelengths pass through more easily. Earth's atmosphere bends some of that warm-colored light into the shadow behind our planet, and there it reaches the moon. That means the red glow of a lunar eclipse comes from sunlight that has passed through Earth's atmosphere. In a way, the moon is being illuminated by all the sunrises and sunsets happening around the edge of Earth at that moment. If you could stand on the moon during a total lunar eclipse, you would see Earth covering the sun. But all around the dark circle of our planet, the atmosphere would glow like a thin red ring. Everywhere along that ring, sunlight would be passing through the air at sunrise or sunset. That light would stretch across space and gently color the lunar surface. Not every lunar eclipse looks exactly the same. Some moons appear bright orange, others turn a dark brick red. A few become so dim that they nearly vanish against the night sky. The color depends partly on what is happening in Earth's atmosphere. Clouds, dust, smoke, and even particles from volcanic eruptions can affect how much light reaches the moon. A clear atmosphere may create a brighter copper glow. More dust in the atmosphere can leave the moon darker and redder. So every lunar eclipse carries a faint reflection of Earth's skies with it. There are several kinds of lunar eclipses. During a total lunar eclipse, the entire moon enters the darkest part of Earth's shadow. During a partial lunar eclipse, only part of the moon passes through that deep shadow. One side may become dark and rusty red, while the rest remains bright. There is also a gentler kind called a penumbral eclipse. The moon passes only through the lighter outer part of Earth's shadow. The change can be so subtle that someone glancing at the sky might not notice it at all. Although the moon circles Earth about once a month, lunar eclipses do not happen every month. The moon's path is slightly tilted compared with Earth's path around the sun. Most months, the full moon travels a little above or below Earth's shadow. Only when the timing and position are just right does the moon pass through it. Lunar eclipses have another surprising difference from solar eclipses. A total solar eclipse can be seen only from a narrow path across Earth, but a lunar eclipse can be watched from anywhere on the nighttime side of the planet where the moon is above the horizon. Millions of people across different countries and continents can look up and share the same changing moon, and unlike a solar eclipse, a lunar eclipse is safe to watch with your eyes. You don't need special glasses or complicated equipment. You only need a clear sky, a view of the moon, and enough time to watch Earth's shadow slowly travel across it. Long before people understood what caused eclipses, the sight of a red moon could be frightening. It appeared without warning. Its familiar light changed color, and the night sky seemed to be telling a story no one could yet explain. Today we understand the movements behind it, but knowing the explanation doesn't make the experience less remarkable. It reveals something even more beautiful. When the moon turns red, we are seeing our own planet from an unusual point of view. Earth's curved shadow reveals its shape. Earth's atmosphere filters the sunlight, and the colors of distant sunrises and sunsets meet on the surface of the moon. Three familiar neighbors, the sun, Earth, and moon, have moved into exactly the right places. For a few quiet hours, their paths become visible in light and shadow. The next time you see the moon begin to darken, watch closely. The red glow isn't coming from the moon. It is sunlight traveling through the edge of Earth's sky, bending into our planet's shadow and reaching across space. A lunar eclipse may happen far above us, but its color comes from home. Have you ever watched the moon turn red during a lunar eclipse? Or would you like to see one? Tell us in the comments. And if you enjoy discovering the curious stories hiding in the world around us, like this video and subscribe for more. Every ordinary thing has an extraordinary story.